Good day. Welcome to another session of Fog Accountancy Tutorials. Today we are going to continue our study on the time value of money, and we are going to focus on annuities. I've already done a lot with the time value of money. We started by looking at the simple interest and the compound interest, and then we looked at future values and present values. We have learned how to calculate future values by compounding, and then we have also learned how to calculate present values by discounting. And we have gone through a lot, solving questions in the process. Today we are going to look at annuities. What we have done previously was to look at mixed stream of cash flows and just a single cash flow and how to compound or discount them. Now here we are going to look at annuities. What is an annuity? So I'll begin by defining what an annuity is. And then I'm going to tell you the two types of annuity that we have. And then from there, we'll look at annuities with future values and then annuities with present values. An annuity is a stream of equal periodic cash flows, okay, or a fixed amount of cash flows that is paid or received for a period of time. So, for example, if you are supposed to receive $100 every year for 10 years, we'll call this $100 an annuity. An annuity comes from the root word annual. Okay, so an annuity means that you are taking annually, or you are paying or receiving the same amount of money every year for a fixed period of time. Then we call that an annuity. So please take note. Now, an annuity could be paid or received. So it could be that you are making an investment and you contribute $100 every year for maybe a period of 10 years. Because it is the same amount of money that you are paying or contributing to your investment fund every year, we call that an annuity. Now, assuming that in year one you paid 100 cedis into the investment fund, year two, you paid 200 cedis. Year three, you paid 150. So once you begin to make it a mixed stream of cash flows, then it ceases to be called an annuity. An annuity must be the same amount of money over a period of 1 year, usually for a period of time. So you pay that every year. Let me say that because of the name annuity, annual. So it's a fixed payment or receipt that is made or received every year for a fixed period of time. That is some total number of years. So once it is the same amount, we call it an annuity. So please take note. Now, this payment or receipt normally is about investment. Okay. Now, this payment or receipt that you make a constant amount every year for a period of time, we have two different classes of annuities. So I'm going to tell you two classes of annuities. The first one is called ordinary annuity. And the other one is called annuity due. So we have two types of annuities. We have ordinary annuity and then we have annuity due. Now, what is the difference? An ordinary annuity is when the payment or receipt is, okay, let's say if it's payment or receipt of cash or cash flows. So it could be a cash inflow or a cash outflow. Now, an ordinary annuity is when the payment is made at the end of each year for the period of time under consideration. So if you are looking at 5 years, you are going to make payment of a fixed amount of money at the end of every year for 5 years. Then we call it an ordinary annuity. It is an ordinary annuity because payment is made at the payment is made at the end of each year. So please take note, because when we start solving questions, these are the things that will differentiate which formula to use. There is a formula for ordinary annuity and there is a formula for annuity due for both present and future values. So we need to be very careful. An ordinary annuity is when payment is made at the end of each year. And then an annuity due is when payment is made at the beginning of each year. So please take note. So when you make the payment for the fixed stream of income or fixed amount of income at the beginning of every year, then we call it an annuity due. But if it is made at the end of every year, we call it an ordinary annuity. So please take note of that. All right. Now, we have already studied present values and future values. Now, we have annuities for present values, and then we have annuities for future values. So what I'm going to do is that I'm going to begin with the future values. I'm going to talk about future value of an annuity. And then when we are done with future value of annuities, we'll come back to present value of annuities. But before that, let us quickly recap two very important points that I have made. That we have ordinary annuity and we have an annuity due. So even as I move to the future value of annuities, we are first of all going to look at the future value of an ordinary annuity, and then we'll look at the future value of annuity due. And in each case, we are going to solve an example to get you to understand what we're talking about. Okay, so we are beginning with future values of annuity. Future value of an annuity. Now, under the future value of an annuity, I've told you we have an ordinary annuity and we have an annuity due. So let us begin with future value of ordinary annuity as a subtopic of an ordinary annuity. Now, the interesting aspect is that when you get a question in an exam, no exam will tell you that this one is an ordinary annuity straightforward or this is an annuity due. You will look at the condition in the question to determine whether it is an ordinary annuity or an annuity due. And each of them has a different formula. If you determine that it's an ordinary annuity, you apply the ordinary annuity formula. If you determine that it's an annuity due, you apply the annuity due formula. So even though you may be provided with a formula sheet, but if you are not very sure or you don't understand what you are doing, you may apply a wrong formula for the question, and that is going to be a disaster for you. So let's quickly look at the formula for future value of an annuity, of an ordinary annuity, sorry. So an ordinary annuity means that the payment is made at the end of each year for the period under consideration. And the formula will be given by, now, first of all, listen. Before I give you the formula, let me explain something to you. We all know that to calculate the future value, a normal future value, which is not an annuity but an amount, it is given as the present value multiplying 1 plus r raised to the power n. This is the basic formula that we know for future value, okay? Now, this present value can be called payment. So instead of PV, we can say PMT. So future value is the payment multiplying 1 plus r raised to the power n. Nothing has really changed. I've decided to replace present value by payment. Payment can replace both present value or future value. Okay, so let me just use payment for now. PMT for payment. Now, it is the same formula. This is the formula for future value. Now, if you want to look at, let's say, an annuity for 4 years, then what you are going to do is that, you know, the formula for calculating the future value is when you are looking at just a single amount of investment. So you deposit, let's say, an amount of $2,000 today, and that is all you have deposited. And you want to know how much it will amount to at the end of, let's say, the 5th year. That one is when you go by this formula. But if you are making series of the same amount of payment every year, then the formula is changing, because now in year 1, you have to find the future value. Then in year 2, the deposit that you make, you find the future value of that. In year 3, the deposit that you make, you find the future value to the 5th year. So the 5th year or 4th year. Then you have to add up all those future values, and that is what we call the future value of the annuity. So if you want to find the future value of an annuity, that is an ordinary annuity, then it means that it's going to be the payments that you make, okay, multiplying 1 plus r. Now, if it is the first year, then it will be n. Okay. Now, plus payment that you make in the second year, 1 plus r raised to the power n minus 1. N minus 1 means you have moved to the second year and you are making another one, plus the payment multiplying 1 plus r raised to the power n minus 2, plus the payment multiplying 1 plus r raised to the power 0 or whatever, or 1. Let me just put it that way, or 0. Now, what we are trying to say is that you are going to add up, you are going to discount separately each deposit for the number of years. So if it's for a period of 10 years, you are going to find a future value for each year depending on when you made the payment. And then when you are done, you add it all up and we call it future value of an annuity, ordinary annuity. Going through this process will be very, very disturbing, because if you are told to do that for 50 years, you would understand the kind of stress you have to go through. So this formula, if you simplify this formula to the end, I'm not here to prove formulas to you, but I just want you to understand the idea behind the ordinary annuity formula that I'm going to provide. Now, if you do this for so many years, it's going to summarize, if you prove it, to give you just one formula, so that when you put the figures into just that one formula, it's going to give you straight away the answer that you are looking for. So I'm going to clean this and I'm going to write the formula for you. This is just a way of telling you the rigor you have to go through. This is not a formula, okay? So I'm cleaning this and I'm going to give you the formula for future value of an ordinary annuity, and that is going to help you to be able to calculate. Now, to find the future value of an ordinary annuity. So now I've made it FVA. The A here stands for annuity. Then it means that it's your payments. So it's your payment or your future value over K or R, where R or K becomes the interest rate. I don't know which one you prefer. So we can use R to represent the interest rate, or you can use K. Then you open a bracket. Now, this bracket that you have opened will be a bigger bracket. So multiplying 1 plus R. So instead of K, we use R for interest rate. Raised to the power N. So like the way we used to compound, minus 1. So this becomes a formula for future value of an annuity due. Please take note. It is the payment or the future value dividing the interest rate or the cost of capital, multiplying the discounting factor of 1 plus R raised to the power N minus 1. Please, this is a formula, and in most cases, it is provided in the exam. So it is not a problem. But the problem is how to identify whether this question I have to use this formula or that formula. That is where the problem becomes. So you may be given a formula sheet, but you may mismatch the formulas. So this is the future value of an ordinary annuity. And this is how it is calculated. And all you need to do now is to get this formula into your head. Okay? The future value, the present value or the payment that is made all over the rate or cost of capital, multiplying the discounting factor times the number of years minus 1. So you see that there is a bigger bracket for all that we are multiplying this, and then there is a smaller bracket that has the 1 plus the rate, the normal compounding factor that we know. So this is the formula for future value of an annuity. We are compounding, but we have generated a different formula for that. Now we are going to solve a question for ordinary annuity. When we are done, then we'll look at the annuity due. So let's solve this question together. Mrs. Linda Agbanyaga is planning her child's university education. She has therefore decided to make periodic contribution towards that. If she deposits 2,000 Ghana cedis at the end of every year into a special account for 7 years, and the bank pays 15% interest on such deposits, how much will the deposits grow to at the end of the 7th year? Now, I want us to analyze this question again very carefully. These are the ways the question will come. A very short and simple question. But how do you know this is an ordinary annuity? Let's go back. Mrs. Linda Agbanyaga is planning her child's university education. She has therefore decided to make periodic contribution towards that. If she deposits 2,000 Ghana cedi at the end of every year, at the end of every year. That is what makes it an ordinary annuity, because the deposit is being made at the end of every year. If the question had said at the beginning of every year, then this would have been what? An annuity due. Please take note. Because we are told the deposits are made at the end of every year, it makes it an ordinary annuity. If it has said at the beginning of every year, then it would have been an annuity due, and therefore wouldn't have used this formula. Because after this, I'll give you the formula for annuity due as well for the future values. But because we are told at the end of every year, then we can use this because it is an ordinary annuity. This formula is only peculiar for ordinary annuities. I'm going to give you another one for annuity due. So please take note and get the formulas right. So at the end of every year, into a special account for 7 years. So the number of years here is 7. And the bank pays 15% interest on such deposits. So you have all the variables that you need provided. How much will the deposit grow? So grow to at the end makes it a future value that you are looking for. Grow to at the end of the 7th year. So once you see grow to at the end of the 7th year, you know we are talking about future values. But as to whether it is a normal future value of an annuity ordinary, or future value of annuity due, that one you need to be able to determine that. So let's solve this question together. So solution. Now, Miss Linda Agbanyaga, whenever you want to start, you always have to put your variables of interest. So here, the annual payment that is being made is 2,000 Ghana cedis. Then the interest rate or cost of capital, or the interest provided by the bank, is 50%. And then also the number of years is 7 years. So all this information is provided for in the question. So therefore, the future value of an ordinary annuity is, then you quote your formula again. It is important to always quote the formula again when solving it. So your payment over the rate of interest multiplying 1 plus r raised to the power n minus 1. This is the formula for ordinary annuity. So you just put that into the formula. Therefore, future value of this ordinary annuity becomes, we go into the question we've already provided, that the amount is 2,000 Ghana cedis all over the rate. Now 50%, you are not going to put the percentage, you are going to convert it to decimals. So it's going to be 0.15 multiplying 1 plus 0.15 raised to the power n is the number of years, which is 7 minus 1. So you can just punch this on your calculator. If you are using financial calculators, it's even easier for you. So you punch this on your calculator. You need to learn. Many students find the punching of this on the calculator to be a very big difficulty or burden. You need to, at this stage, learn how to punch these things on the calculator. So you can punch this all at a go on the calculator and you have your answer, or you can decide to punch these two first and then you multiply by the answer of what is in the bracket. So let me do it that way for you if you want. So future value of an ordinary annuity gives us 13,333.33 times, and then when we punch this on the calculator we have 1.66. Okay, so the future value of the ordinary annuity is 22,133.33. This is the final answer. So you know what? It means that if Mrs. Linda Agbanyaga decides to deposit 2,000 at the end of every year for 7 years with an interest-bearing rate of 15%, at the end of the 7th year, this is the amount that she will get from that investment. And if you multiply 2,000 by 7, you are getting 14,000. So you realize that it is more than just putting the money down. So the investment has yielded more returns than when she had put the money somewhere without any interest-bearing facility. So this is how to solve a question on future value of an ordinary annuity. I'm sure this is very understandable for you. Now we are moving on to future value of an annuity due. And when we are done with the future value of an annuity due, we'll move on to the present values. Take note of this. I'm going to also take you through the future value of an annuity due. Okay, so let's look at future value of an annuity due. Now, when we say an annuity due, we have already explained that it is when the deposits or the payments are made at the beginning of a year. Now, if payments are made at the end of the year, it means that the deposits do not qualify for the interest within the first year, because banks or investment houses pay you interest because they have used your money and then they have to pay you. If you deposit at the end of the year, the first year had already elapsed. So you are not going to get any interest at or for the first year, let me put it that way. But if you deposit at the beginning of the year, then it means that they are going to use that money for the first year as well. And you are going to get interest for the very first year. For the other years, you definitely get interest, because even if you deposit at the end of the first year, they will use this for the second year. But if you deposit at the beginning of the first year, it means that for the first year, you will get interest. But with the ordinary annuity, you are not getting interest for the first year. So these are the differences. Now, it makes the formula a little different. So if you want to find the future value of an annuity due, I've added a small a and this time a small d. With the ordinary annuity, I just said a. So future value of AD, annuity due. Now, the formula will not change much. It's the same thing, the payment or the present value, payment over R. Now, this R is a mix. It could be K, it could be I. It's just about the interest rate. Multiplying 1 plus R raised to the power n minus 1. Now, is this not the formula for ordinary annuity? Yes, it is. But because they will have interest for the first year this time around, we are going to add this. We multiply again plus with 1 plus R. So that is the difference. That with the ordinary annuity, it ends here. But with the annuity due, because they are going to get interest on the first deposit, then it means for the first year, then it means we need to add one more compounding factor. Okay, so the ordinary annuity ends at the bigger bracket, but with the annuity due, you add one more compounding factor to cater for the first year that the investor is going to get that particular interest. So that is the formula. So this, please take note. So in an exam, even if you are provided with the formula sheet, this will be on the sheet. The ordinary annuity formula will be there. And if you read the question, whichever formula that you pick, you can put in the figures and get some answer. But as to whether what you have used is the right for the question is a problem. So let us solve a question with an annuity due and let's see the difference. Okay. Suppose you deposit $1,000 per year for 3 years at the beginning of the year in an account earning 6% interest. What is the account balance at the end of the third year? I repeat, suppose you deposit $1,000 per year for 3 years at the beginning of each year in an account earning 6% interest. What is the account balance at the end of the third year? This is very straightforward. Once you see at the beginning of each year, then it is an annuity due. The previous one was at the end of the year, so that became an ordinary annuity. But at the beginning of each year becomes what? An annuity due. So we are depositing $1,000 per year at the beginning of the year in an account that is earning 6% interest. So the solution, you always have to write your metrics down. The payment is $1,000 per year. Then the rate is 6%. And then the number of years, n, is 3 years. So you always have to put these things down before you start solving. So therefore, your future value of the annuity due will be the payment. I told you to always quote the formula. So over R, then you multiply by 1 plus R raised to the power n minus 1. Multiplied by 1 plus R again. So this is how we calculate for the annuity due. So therefore, the payment here now is $1,000 over the rate of 6% to be 0.06. If you make it 0.6, that is 60%. So take note, this is 6%. Then multiplying 1 plus 0.06 raised to the power n, and the number of years is 3 minus 1. You close it, you open another bracket, 1 plus 0.06. Very interesting. So if you know how to calculate this directly from your calculator, you can punch and you will be marked correctly. Or you can still find the value of this and then multiply by the discounting or the compounding factor. Sorry. So let me still use that approach for you. 1000 divided by 0.06. You put it down, then you multiply by the answer of all this. In fact, you can even use annuity tables to find the figures without punching on your calculator. So some of you need to learn how to use annuity table, but I'm teaching you how to calculate so that even if you don't know how to use annuity tables, you'd be able to calculate this. So we have $16,666.67. That is when you divide this, multiplying 0.2025. Okay, so this is how it's going to be. That is, we have found the final answer for all that. So therefore, the future value of annuity due is $3,375. Yes. So this is the future value of the annuity due. It means that if the investor puts in 1,000 at the beginning of each year for a period of 3 years at an interest rate of 6%, this is what the investor is getting at the end of the 3rd year. So that is the future value of an annuity due. I am sure by now you have learned how to differentiate an ordinary annuity from an annuity due, and I'm sure you are going to stay consistent with the formulas that matches the right question. Now, in fact, here it is easier because I have treated each of them and solved each of them their questions. I'm going to also look at present values. That one to look at the ordinary annuity formula for present value and then ordinary annuity due formula for present value. So the formulas are going to even be 4. And then we have already studied other formulas under compounding and discounting, normal future values, normal present values. So assuming that you are reading a question, if you don't really understand what you are doing, even though you may have all the formulas, you will not know which formula should be used for which question, except you really understand the differences that I have explained between an ordinary annuity, an annuity due, a normal future value, a normal present value, and all that. You really need to understand that, and that is going to help you. Okay, so this will bring us to the end of part 1 of our video on annuities. In the part 2, we are going to look at the present value of annuities as well. Remember to subscribe to this channel if it is your first time. Share this video, let others also have a benefit. And until we meet again for the part 2, it's bye for now. Thank you.